Solid fuels. The main solid fuels are wood, peat, lignite, coal, and charcoal. Wood is derived from trunks and branches of trees. It contains about 15% moisture after air drying. Wood contains lignocellulose wood. Bulk mainly consists of alpha cellulose and a very small amount of beta cellulose, resins, and proteins. The average composition of wood on a moisture-free basis is 55% of carbon, 6% of hydrogen, 43% of oxygen, and 1% of ash content. Wood is largely used as domestic fuel. Its use as engineering fuel is restricted. The calorific value varies from 3,500 to 4,500 kilocalories per kilogram. Coal is the most important solid fuel and derived from prehistoric plants. It is a highly carbonaceous matter composed of carbon, hydrogen, nitrogen, and oxygen, and other non-combustible inorganic matter, that it has been found because of alternation of plants under certain favorable conditions. Coal is a natural fuel formed by the slow carbonization of vegetable matter buried under the earth some thousands of years ago. Vegetable matter is first transformed into peat, then to lignite, then into bituminous coal, and finally to anthracite. So this transformation period extends over millions of years through a continuous process. The continuity can be proved graphically by plotting oxygen and carbon percentage of coal at different stages of formation. Coal is classified into four kinds based on the carbon content and the calorific value. It classified according to its four stages: peat, lignite, bituminous coal, and anthracite coal. Peat is regarded as the first stage of formation of coal from wood. It is brown, fibrous, jelly-like mass. It contains 80 to 90% moisture that is considered as an economical fuel. The composition of peat is 50% carbon, 6% hydrogen gas, 35% oxygen, and 2.5% ash. The calorific value of peat is 5,400 kilocalories per kilogram. It is a low-grade fuel due to high water content. It is used as domestic fuel in steam boilers, power stations, and gas producers. It is also used as fertilizer. Low-temperature carbonization of peat is used for getting peat coke and its byproduct. Peat is easy to ignite and burns freely to give a long, pleasant flame. The second stage is the lignite, or a brown coals, which are soft, brown, and colored. It is also called the immature form of coal. It contains about 20 to 60% moisture. When air dried, lignite contains 60 to 70% of carbon, 20% of oxygen. Its calorific value range from 6,500 to 7,000 kilocalories per kilogram. It burns with a smoky flame. It is powdered, dried, and pressed into briquettes and used for domestic purpose, for boilers, and for production of producer gas. The third one is the bituminous coal, which are black and usually banded with alternate very bright and dull layers. Based on carbon content, it is classified as sub-bituminous coal. This first picture on the left, it contains 70 to 78% carbon, 4 to 5% hydrogen, and 20% oxygen. The air-dried material has moisture content of 10 to 20%. The calorific value is 6,800 to 7,600 kilocalories per kilogram. It ignites easily, and if low in sulfur content, it uses for gaseous fuel production. The next classification is the bituminous coal, which is this image at the middle. It contains about 78 to 90% carbon. Its calorific value is range from 8,000 to 8,500 kilocalories per kilogram. It used for combustion in household, industrial furnace, and oilers, railways, locomotives, and thermal power stations. By carbonization and gasification, it is converted to coke, gaseous fuels like producer gas, water gas, coal gas, liquid fuels like coal tar fuels. Next is a semi-anthracite, which is the picture at the right side. It is intermediate between the bituminous coal and the last stage of coal, which is the anthracite. It ignites more easily than anthracite. When air-dried, its moisture content is 1 to 2%. Volatile matter is 10 to 15%. And its calorific value range from 8,500 to 8,800 kilocalories per kilogram. The final stage of coal is the anthracite. It is the highest ranked coal, having highest percentage of 92 to 98% carbon, 3% oxygen, 3% hydrogen, and 0.7% nitrogen. It has a lowest volatile matter and moisture. The calorific value range from 8,400 to 8,600 kilocalories per kilogram. It burns without smoke, but ignites with difficulty. It possesses no cooking power. Its chief use are in boilers, domestic ovens, and metallurgical furnaces. Coke. Coke is the solid, lustrous, and porous mass left in the distilling pot after destructive distillation of coal. The process converting coal into coke is called carbonization. In this process, coal is heated in absence of air to a sufficiently high temperature, under which volatile are driven out, leaving a solid, lustrous, dense, porous mass known as coke. Coke possesses much strength and porosity compared to coal. By cooking the undesirable sulfur content of coal, it removed from the coal, and due to lower volatile matter content of coke, it burns with a short flame. All these properties of coke make it suitable for metallurgical process compared to coal. So we have two types of carbonization. The first one is the low temperature carbonization. which carried out at temperature between 500 to 700 degrees Celsius. The yield of coke is 75 to 80%, and it contains 8 to 12% volatile matter. The coke obtained is not mechanically strong but highly reactive and can be easily ignited to keep a smokeless flame and used as a domestic fuel. Low temperature carbonization yields a very complex mixture of higher phenols, substitute aromatic hydrocarbons, and other nitrogen and oxygen containing compounds. Disinfectants are made from this tar. The coal gas obtained has calorific value of 6,500 kilocalories per cubic meter and is richer in hydrocarbons and poorer in hydrogen compared to the gas produced by high temperature carbonization. The crude spirit corresponds to crude bed salts of higher temperature carbonization but contains greater amount of paraffins, naphthalene, and olefin. The higher temperature carbonization is carried out at 900 to 1200 degrees Celsius, producing coke of good porosity, hardness, purity, and strength, and can be used in metallurgy. As all the volatile matters are driven off, the yield of coke is 65 to 75% containing 1 to 3% volatile matter. The retorts used are made of bricks. The gas and tar yields are lower. The calorific value is lower, about 4,500 kilocalories per cubic meter. Here are the byproducts of carbonization of coal and producing coke. By carbonization, you get the volatile part and produce coal tar, ammoniacal liquor, coal gas, and gas carbon. Now, this coal tar undergo a process which we call fractional distillation and will be discussed later, produces residue pitch, a light oil, middle oil, heavy oil, and anthracene oil. Here are the other byproducts of carbonized coal according to the content of oil. For the light, we have benzene, toluene, xylene, cumene. For middle oil, we have naphthalene, phenol, cresol, pyridine. For heavy oil, we have cresol, xylene, naphthalene. And for anthracene oil, we have phenanthrene, anthracene, and quinoline.